Hello everyone, myself Sai Prasad, Alexan, Ahlaveth High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We have started the different concepts of our 2B, that is starting from the geometrical parts such as circle, system of circles, parabola, and we also learned the basic calculus part, that is integrals. With the continuation of that, let us learn a new chapter, that is definite integrals. What is this particular term? Just I will give you a brief introduction about what is indefinite and definite integrals. If you remember, in indefinite integrals, we always used to write plus c. Why? I gave you a simple explanation in the introduction of that. That is, whenever we find the integration of a particular differentiated object, that is, if there are few circles, if I want to make it as a perfect square or a big circle, we need few more small spaces in between. That is the area which we take it as a constant. Whereas in the definite integrals, we don't have that particular thing. That is, we'll have a fixed range of integrals. Okay, is it clear? Fine. Just have a look that definite integral. What is that we are going to learn here is, if I say integral f of x is capital F of x, then this integral can have a range of different limits. Let us say if this f of x is in between small a and b, then my integration is given as f of b minus f of a. What does it mean? It tells that first we have to integrate this, then we have to substitute this lower limit and upper limit. These are called as lower and upper limits, and we always tells that this function is going from a to b. Is it clear? For example, if f of x is a function, then it has some area from a to b. Clear? So this will be my small f of a and this will be my capital F of a, and the total area is given by f of b minus f of a. Is it clear? Simply first integrate it, you will get something. First substitute b, then substitute a and subtract. That's it. Clear? Did you understand? This is how we are going to find the integration, or we can tell it as particular integral at this limit. Okay, it goes from lower limit to upper limit. Clear? Fine. These are the few properties of definite integrals. That is, if the integral is from a to b, if I want to interchange the integral, then I can write minus here. Okay. If I want to divide the whole integral from, let us say from a to b, there is some particular point c in between. So I can write the whole AB as a to c and c to b. Okay, that's what I wrote here. A to b can be written as a to c plus c to b, the same function ka integral. Clear? Good. Next, if the function is from 0 to a, then the property can be written as 0 to a minus x. Instead of x, we can write it as a minus x. If it is from a to b, then I can write a plus b minus x. This is one more formula. Clear? Next, if my function is from minus a to plus a, so I can divide it and write it as double of 0 to a, because this and this both are same. I can write it as double of 0 to a. Fine. Next, if I have 0 to 2a, let us say 0a to a. Okay, 0 to 2a can be written as double of 0 to a, the same. Is it clear? These are the basic formulas which we are going to use in this chapter. Is it clear? What are the prerequisites of this chapter? First, we have to know how to differentiate it. Then only we will know how to integrate it. Thirdly, we have to know these formulas. Clear? Shall we start doing few problems of definite integrals? Let's do. Look at the questions here. He is asking us to evaluate these particular questions. The questions, remember, he has to give lower and upper limits. Okay, as of now, we are not going to calculate anything, just integrating, substituting upper, lower, subtracting. Okay, see here, x plus 1 ka integral. First tell me let us write like this, x plus 1 ka integral is x square by 2 plus x. Let me write a square bracket like this from 0 to 5. It indicates that it is being integrated. Now we are going to substitute the lower and upper limits. Okay. Now first substitute upper limit, 5 square by 2 plus 5 minus 0 plus 0, that so you can leave. 25 by 2 plus 5, LCM is 2, 25 plus 10, which is 35 by 2, that's it. Clear? Fine. Look at the next question. X plus e power 2x, x ka integration x square by 2, e power 2x ka integration e power 2x by 2, isn't it? Whatever there is instead of x, we are going to differentiate and put it in the denominator. We have to substitute 0 to 4. First substitute 4 square by 2 plus e power 2 into 4 by 2 minus 0, however 0 plus 0. Clear? 4 square is 16, 16 by 2, 8 plus half e power 8. Right, we are not writing c here. Why? Because already it is a specific value. It doesn't have any functions or any dependent thing. Right, there is a number, there is a number. Yes. Next, 2x by 1 plus x square. How do we integrate it? This is a direct formula which you know, that is the numerator is differentiation of denominator, isn't it? From here I am going to write everything in the direct form itself. So the direct answer here it is log 1 plus x square from 2 to 3. Now we have to substitute it. What do we get? Log 1 plus 9 minus log 1 plus 4, which is log 10 minus log 5. Log a minus log b, what is the formula? Log a by b. Log a by b, which is log 2. Right? Next, the last thing, 2 plus 2 cos theta d theta. So this thing we did in our integrations also, right? Let us take 2 common here. If I take 2 common here, I will get it as 1 plus cos theta d theta. Take root 2 outside. What is 1 plus cos theta ka formula? 2 cos square theta by 2 under root 2 cos square theta by 2 d theta. Now apply root 2 two things again. Root 2, again one more root 2, 0 to pi cos theta by 2 d theta. Right? Root of cos square is obviously cos. So root 2 into root 2 is 2. Cos theta ka integration sin theta by 2 by 1 by 2. Now I have to substitute 0 to pi. 2 will go to numerator, 4 sin pi by 2 minus obviously it is 0. So 4. What is sin pi by 2? Sin 90 is 1. Therefore the answer is 4. Is it right? Are this not easy? The basic integrals will be very easy, and here we are directly substituting the upper limits and lower limits. Clear? Shall we do few more problems? Let's do. Look at these questions here. Now he is asking us to find integral 0 to 2 mod 1 minus x dx. So whenever you find the modulus, you have to write the limits for it. So how do we write? Just remember, mod 1 minus x is positive when x is greater than 1, isn't it? Yes or no? No. How? If 1 minus x is greater than 0, then 1 is greater than x. So x should be less than 1. Right? Next, if it is 0, then x is equal to 1. This is 1 minus negative of 1 minus x when x is greater than 1. How? If this is less than 0, I mean this is negative. So I can tell that 1 is less than x. So therefore x is greater than 1. Clear? These are things you know. So I can write this whole 0 to 2 as, now we are going to use the formula. 0 to 2 can be written as 0 to 1 and 1 to 2, right? So let us separate it. 0 to 1 mod 1 minus x dx plus 1 to 2 mod 1 minus x dx. Can I write? 0 to 1 bole to it is x is less than 1. So for x is less than 1 it is 1 minus x. So let us remove mod and let me write it as 1 minus x dx. Clear? Next, from 1 to 2, that is x is greater than 1, obviously it is negative. So it is 1 to 2 1 minus x dx. I have written minus here. Clear? Now just integrate it. What do we get? 1 ka integration is x, x ka integration is x square by 2. Substitute from 0 to 1. Again 1 ka integration is x, x ka integration is x square by 2. Substitute it from 1 to 2. Clear? So here 1 minus 1 by 2 minus 0, however here 2 minus 4 by 2 minus 1 minus 1 by 2. Is it right? Once again see here, 2 minus 2 square is 4 by 2 minus 1 minus 1 by 2. Clear? So let me simplify this. 1 minus half is 1 by 2. 2 ones are 2 twos are. This is 0. This is also 0. Here minus to minus plus 1 minus half is half. Half plus half is 1. Is it right? So you have to remember that whenever you get a mod, you have to write it in the limited form. So it will have a limits, which means it is going to be positive for a particular thing. After that it will be 0. After that it will be positive, like that. Clear? Next, 2 minus x. What is the range here? 2 minus x mod is equal to positive when x is less than 2. It is 0 when x is equal to 2. It is negative when x is greater than 2. Right? So we can write 0 to 4 as, let us segregate it, 0 to 2 and 2 to 4. So is it clear? Fine. The two things you have to get out is, first thing, why only 0 to 2? Why can't we write as 0 to 1, 1 to 2, 2 to 4, like that? Is the question, the limits we got with respect to 2. Okay, which means it has a limit at 2. Is it clear? So we can tell that this can be written as integral 0 to 2 mod 2 minus x dx plus 2 to 4 mod 2 minus x dx. So from 0 to 2, that is x less than 2, the mod 2 minus x is positive. So this is 2 minus x dx. From 2 to 4, the x is greater than 2, so it is negative. Integral 2 to 4 2 minus x dx. Now 2 ka integral is 2x, x ka integral is x square by 2 from 0 to 2. 2 ka integral is again 2x, x ka integral is x square by 2, 2 to 4. Now let us substitute. 2 2s are 4, 4 square by 2 is 2. Again this is 0 minus 2 4s are 8 minus 4 square is 16, 16 by 2 is 8 minus again 2 2s are 4, 2 square is 4, 4 by 2 is 2. Is it clear? Check once again. I am writing it directly here. Once I will substitute 4, 4 2s are 8 minus 4 square is 16, 16 by 2 is 8. Next 2, 2 2s are 4. Again here 2 square is 4, 4 by 2 is 2. Clear? Now 8 8 will get cancelled. 4 minus 2 is 2. Minus to minus plus 4 minus 2 is 2. Answer is 4. Is it right? No more difficulties using modulus. Clear? Shall we move on to the next problem? Let's do. Look at the next question here. He is asking us to integrate x square by x square plus 2. How do we solve this? Just tell me. Denominator is x square plus 2. Numerator is only x square. So let us add and subtract 2. Fine. See here. Now let us add and subtract 2. So what do we get? Minus 1 to 2 x square plus 2 by x square plus 2 minus 2 by x square plus 2. Is it right? This both will get cancelled. I will get it as minus 1 to 2 1 minus 2 by x square plus 2. Yes, 1 का integration क्या होगा? That will be x minus 2 1 by x square plus 2. This can be written as root 2 whole square. Right? What is the formula of 1 by x square plus a square? That is nothing but 1 by a tan inverse x by a. 1 by a tan inverse x by a. Right? Now we are going to substitute minus 1 to 2. Done. Clear? So let me substitute 2 first. 2 minus here this will be 1 by 2 root 2 tan inverse 2 by root 2. Clear? Minus, now let us substitute minus 1 minus 1 minus 1 by root 2 tan inverse minus 1 by root 2. Is it clear? So when do I get plus root 2 and tan inverse minus 1 by root 2? Do I get root 2 in tan? No, right? So let me put it as it is. So this will be 2 minus 1 by root 2 tan inverse root 2. Here minus to minus plus 1. Again minus to minus plus 1. 1 by root 2 tan inverse minus 1 by root 2. If you want to simplify, you can do it. Here 1 plus 2 is 3 minus 1 by root 2 tan inverse root 2. Here plus 1 by root 2 tan inverse minus 1 by root 2. Clear? Based on the condition, you can write as minus pi by 2 or plus pi by 2 or something 3 pi by 4 like that. Okay? Is it clear? Fine. Look at the next question here. Integral minus pi by 2 to plus pi by 2 cos x by 1 plus e power x dx. So how do we solve it? Just use all the properties which you can use. Here we have used one property. What did we use? We didn't use anything here. No, right? We used this formula of that. Clear? Next, here we will, let us use one formula here. What is it? Can I add, instead of x, can I write it as a plus b minus x? Yes. So let me use the formula. Integral f of x dx from a to b can be written as integral 0 to b f of a plus b minus x dx. Right? So let me write it as, first let us take it as I. Okay? Minus pi by 2 to plus pi by 2 cos power minus pi by 2 to plus pi by 2 minus x divided by 1 plus e power minus pi by 2 plus pi by 2 minus x dx. Clear? Now if you observe, these both will get cancelled. These both will get cancelled. I will get it as I is equal to minus pi by 2 2 pi by 2 cos of minus x by 1 plus e power minus x dx. Is it right? So what is cos of negative x? Which is always a positive. Right? So this is minus pi by 2 to plus pi by 2 cos x divided by e power minus x can be written as 1 by e power x. So this is 1 plus 1 by e power x dx. Is it right? Now let us take LCM of this. What do I get? We'll get e power x plus 1 by e power x. So that is nothing but e power x in numerator by 1 plus e power x in denominator. Is it? So now let us add these both terms, the quotient term and the thing we got here. So check, what do we get? I plus I is equal to integral minus pi to plus pi by 2 cos x by 1 plus e power x is the question, and here minus pi by 2 to plus pi by 2 e power x cos x by 1 plus e power x is this thing. So if I take this, 2y is equal to integral minus pi by 2 to plus pi by 2, cos x by 1 plus e power x as common. So, I will get it as 1 here and here e power x dx. Is it? Now, if we observe, these both will get cancelled, right. So, what is the integration of cos x? Cos x ka integration is sin x from minus pi by 2 to plus pi by 2. What is sin pi by 2? That is 1. What is minus sin of minus pi by 2? That is minus 1. 1 plus 1 is 2. Therefore, I is equal to 1. How 2i equal to 2 bole to I will be 1. Is it right? Did you understand? Thing is, we have used this particular formula in this question. Without knowing that, we can't easily solve it. If you want to use, you can use 2 into 0 to pi by 2. You can use that kind of thing also, right. What if you use only pi by 2? Then also you will get here cos of pi by 2 minus thing, you will get some sign, you will get some other terms. You have to simplify more in order to get this answer. Is it clear? What all we learned in this session? We started with the introduction of definite integrals. We solved a few problems and we learned properties, and we also solved few problems based on the properties of definite integrals. Clear? Fine. Hope everything is clear for you. Let us meet in the next session with the more problems of definite integrals. Thank you.